Okay, in the, there's going to be 2 more videos, so 2 more parts to this chapter 9. This is the most important of the chapters for this section of the course. And I just want to go back to this point right here, where we had described that point 2 was the optimal point. Now, what was happening here, right, is that point 2, the marginal utility per dollar spent was equal across the 2 goods. As you buy more or less of the good, the numerators change. The denominators never change. Prices never change. But the numerators would change. So again, at point 1, the marginal utility per dollar spent on good C is greater than good S. Right? So as a consequence of that, right, I buy more of this good, right? In the act of buying more of the good, the numerator falls, and vice versa. Now, the final thing I want to do, and the reason why I wanted to make sure I didn't want to add to an already very long video, is a very important drop-down graph. So, we know already that if I have, I don't know, I'm going to pick 2 goods. Let's make them markers and TVs. It's hard to come up with lots of different examples here. Okay. Now, we can all agree that this is our optimal point, right? The indifference curve is just touching the budget constraint here. So then the question would be, what happens when we change the price of a good? More specifically, what happens when we change the price of markers? And markers is the only thing that changes. We know that nothing would be affected on the indifference curve, correct? Because the indifference curve is drawn where the slope is the ratio of the marginal utilities. So, there was nothing, by just changing the price of markers, nothing theoretically would happen to the marginal utility of markers, nor would anything happen to the marginal utility for TVs. So changing the price of markers would not in any way affect these indifference curves. Now, what about the budget constraint? Well, the budget constraint has 3 components. It has income. Obviously, income wouldn't be affected here. It would have the price of TVs, something that wouldn't be affected by the price of markers. And it also has the price of markers. So it's the price of markers variable, and it's going to have an effect on my budget constraint here. Now, what's it going to do? If I decrease my price of markers, let's get my eraser here. If I decrease my price of markers, what it's going to do is it's going to pivot outward my budget constraint. It pivots it outward because, right, in this case, the price of markers is falling. That would mean that this would get flatter because this is the price of the good on the x-axis. The numerator would be getting smaller and the denominator would be staying the same. So, right, in this picture here, let me just redraw this here to make this even a little bit clearer here. I have a budget constraint that is now getting flatter. As evidenced here, right? It's now it has now been flattened somewhat, making the new optimal point, whereas it was once 0.1, now being 0.2. Now, and this is very important, what if we draw a drop-down graph? where the variables are now different. Quantity of markers, price of markers. We had the price of markers falling. And what I'm going to do here is make drop-down lines here to reflect the optimal points in terms of quantity. And then all we have to do is describe the price. Let's say that at 1, the price was equal to $4, and at 2, the price is equal to $2. I'm making these numbers up, but we did know that the price had to decrease. Well, what that would mean for us is that we could plot out those points. $4 price, the quantity at 1. The $2 price, the quantity for 2. That right there, my friends, is the demand curve. How we graphically derive the demand curve is coming from the optimal points from our preferences as described by the indifference curve and our budget constraint. Now, along this demand curve then, we know that total utility, total ordinal utility, must be increasing, and that it must be the case that the marginal rate of substitution must be falling along this as well. More specifically, that the marginal utility for markers must be falling. Okay, for the very last part of this video, now I'm sure I could go back and look at the videos I've just made. I want to make sure that I covered one thing enough, right? And I don't believe that I have. In the example that we just had, we had markers in TVs, and I had a indifference curve that looked like that, where the total ordinal utility was constant across the indifference curve. These types of indifference curves have a name, actually. They're called Cobb-Douglas. Cobb-Douglas indifference curves are basically two goods that have no relationship to one another. But we know that some goods do have relationships with one another, right? That goods could be perfect substitutes or even perfect complements. In those cases, the indifference curves actually are shaped differently. If this was markers and pens, goods that at some degree might be perfect substitutes. These have a production possibility, or not production, indifference curve that is linear, and it's actually a straight line. Notice what would happen with the budget constraint is that the budget constraint would actually completely cover that indifference curve. So all of the points would actually be optimal points. Or the other extreme would be that they could be perfect complements. And so that would be like quantity of markers and let's say quantity of whiteboards, right? Markers and whiteboards being used in a joint fashion, right? A complementary fashion. Well, now my indifference curves are L-shaped, meaning that the budget constraint now would touch it at only one point, at the corner point. Okay. I'm going to stop the video here, and then I'm going to go over a 14-slide PowerPoint, which will conclude this, the most difficult chapter in this section. Okay, so one more video to go, and this chapter will be done.